Okay, welcome everybody to the next installment for the Riverkeeper webinar series. Everything that you need to know about swimming in the Hudson River. Just for introducing myself first, my name is Katie Leung. I'm the Senior Volunteer and Outreach Coordinator. Before we go into the webinar tonight, just want to give a couple of things that you can know. I believe that everybody is muted, so I don't think that you have the capability of unmuting yourselves. But we do have a Q&A section at the end of the presentation. So if you have any questions, you can definitely put them into the Q&A at the bottom panel. And yeah, we will do our best to get to everybody's questions tonight as time allows. We will end this webinar at 7 o'clock. There's also an option to turn on captioning if you need. So if you go into your bottom panel, you'll see captions, and you should be able to turn on the captions, so you have the transcription. Okay, so for those of you who already know Riverkeeper, I just want to welcome you, and thanks for tuning in to learn more about one of the issues that we are taking on right now. And for those of you who are new to Riverkeeper, I also want to welcome you as well, and thank you for tuning in to learning more about what we do. So just to give like a very brief overview for those of you who are new to Riverkeeper, just want to say that Riverkeeper is an environmental nonprofit that works to protect and restore the Hudson River, and we protect it from source to sea and safeguard drinking water supplies. And we bring together a unique combination of tools to carry out our mission, including science, law, community partnerships, and on the water patrols. And in tonight's webinar, you will be hearing about all things swimming in the Hudson River, including why there is limited public access, why there are only 4 swimming areas that are open along the river's 150-mile stretch, even when much of the Hudson River is actually safe to swim in most of the time, and how we can ensure that the river is safe for our communities to swim in now and for the future generations. We also have an action item. I did put it into the chat before we started recording, but I'll put in the chat once after I introduce our speakers for tonight. So we will go into introducing our speakers. So I would like to introduce to you 2 of our directors at Riverkeeper, who are the experts in swimming in the Hudson River, and they're also working to help open up more public access to the river. First, I would like to introduce Dan Shapley. He's our Senior Director of Advocacy, Policy, and Planning. He's a lifelong Hudson Valley resident who joined Riverkeeper back in October 2011. And he was previously he previously directed and managed Riverkeeper Science and Control, Water Quality, and Membership programs. And his work has influenced state, regional, and local initiatives, including the Clean Water Infrastructure Act, the Drinking Water Source Protection Program, and the Drug Take Back Act. He also serves as the technical advisor to the Hudson River Drinking Water Intermunicipal Council, also known as the Hudson 7, and he's also a board member of the Hudson River Watershed Alliance. I will also like to introduce to you Shannon Roback, who is our science director. So prior to joining Riverkeeper in 2023, Shannon was the associate director of the Water UCI Center at the University of California, Irvine, and Environmental Health Science faculty at the California State University. Her academic work is focused on characterizing sources of pollution, determining environmental health effects, and developing remediation strategies for a variety of water contaminants, particularly contaminants of emerging concern. And she's also worked at and with a number of local, state, federal water agencies, as well as tribes, in assisting with improvement of water treatment technologies and the expansion of monitoring programs. And outside of her work, she is a surfer and a paddle boarder, and is very passionate about protecting our waterways to ensure that they are safe and healthy for recreation, for many species that inhabit them, and as a source of drinking water. So without further ado, I'd like to hand everything over to Dan and Shannon. So please take it away.
Great, thanks, Katie. Dan Shapley, and I'll kick us off. And I want to welcome you all. It's really great to see the names pop up in the chat here. I'm seeing a lot of old colleagues and friends, swimmers, kayakers, swim advocates, pool operators. So it's really a great crowd, and we're looking forward to speaking with you today. So as you know, we're here to talk about everything you need to know about swimming in the Hudson. And if we don't cover everything, you have the Q&A instructions from Katie. So let's go. All right. So everything you really need to know in just a slide or two. Most of the river is safe for swimming most of the time. And Shannon will tell you more about our sampling data that really provides the basis for that fact. Unfortunately, though, water quality in the Hudson still can be risky, especially after rain. That's where we have the most concerns. Importantly, we have very little access to safe swimming on the Hudson River at public beaches and river pools. We want more of it. To have more of it, we need to update our beach regulations, and we'll explain a little bit more about what that looks like. And of course, we need to continue to improve water quality. Now, importantly, climate change is going to have be a big factor in this, as it is with so many issues that we work on. We're going to need to swim. We just have come through together this intensely hot, humid summer. I don't think I'm the only one that experienced it and the only one who wanted to get in the water. That's the norm, right? It's the norm plus. We're going to see more and more of that, and we need to make more opportunities available to safely swim just to cool off. Unfortunately, also, the changes in precipitation especially are going to make it more challenging to continue to improve water quality. So we'll talk about all of this a little bit as we get into our presentation. Importantly, and this is the exciting thing, like, we can do this. We can have more beaches. We can have more swimming. It's right there. We just need the will. We need the vision, and we need to put it into place. And that's really what we want to try to achieve through efforts like this and talking to more people about this topic. So, excuse me, people swim. These are all pictures of people swimming in the Hudson River. And these are swim events. Athletes as well as enthusiasts who go out and enjoy the river. We just had the Newburgh to Beacon swim a couple weeks ago, the Mermaid Festival. We've got the Lighthouse swim coming up. Riverkeeper participated in a polar excursion into the river at Ossining this winter. It was a blast. These are fun events, and it's just evidence that it can happen. It is happening. If you had any doubt whether people are swimming, they are swimming. It is happening. This is just a chart to show the level of participation in those public swim events in the Hudson River and in parts of New York Harbor, this chart. And this might look like a declining trend, but the gaps in the more recent years are really a result of the New York City Triathlon having been canceled in several years. That's usually the biggest swim event of the year with the most participants. And unfortunately, excessive heat, water quality, and COVID have have prevented that event in several years recently. But we're seeing strong improvements in participation in several other swim events. And what this tells me is, again, this is the vanguard. People are swimming, and these public swim events are the evidence that people want to swim and they can swim. We need to make more access for the rest of us to enjoy the river on a typical day, not as part of a special event only. So here's what it looks like right now. We have 3 public beaches, 2 in Ulster County, 1 in Westchester. We have 1 private beach in Westchester, and we have the river pool at Beacon. That's it. 5 areas to swim, And to compare, there are 200 or more than 200 beaches on Long Island Sound, our sister estuary, just over the edge of the map there. So we really have a huge gap in access in our river. And that's something that we really want to catalyze the conversation around and the action around to see more swimming realized and possible in our region. Now, at these locations, there is Department of Health testing of the water quality. Some places it's weekly, some places it's monthly. Monthly is not frequently enough in our view, but that's what some beaches get by with. And what the testing is for, and you'll hear more about this when Shannon speaks, is something called fecal indicator bacteria, Enterococcus or E. coli, depending on where the beach is. And these are indicators that pathogens could be in the water that can make you sick. And that's the main concern we have with water quality when it comes to swimming. Again, you'll hear more about that. But the important thing to know is that these are the places where you have a lifeguard. These are the places where the water quality is tested. These are the places that are really managed to make swimming very safe. And there are very few locations like that. Which isn't to say there aren't more places that can be swimming areas, and in fact, are being used in that way. There was a study the state did about 20 years ago, identified these locations that are color-coded on the map, and I should say this map shows the tidal portion of the Hudson River, the tidal Hudson River estuary from the Capital District at the top down to New York City at the bottom. And you can see that the state identified 6 sites that were feasible for beaches with relatively little work, 8 sites that required some more work, and then 4 that looked good but had some substantial barriers, would take significant effort to make into beaches. So we have a lot of options that the state itself has identified that are possible for the Hudson that could be new beaches based on this study. Significantly, we don't know how many sites might be suitable for a river pool. The Beacon River Pool folks have been looking and scoping some new sites. That's exciting. I think we could use a comprehensive look at the river broadly, because there are a lot more options for river pools potentially than beaches, because a beach takes particular connection to the water, whereas a river pool, a lot of piers, a lot of urban waterfronts really could be suitable where there might not be a beach option. And I should say there's no testing at these locations, despite them being potential feasible beaches. These are not places the government tests. We also see through the observations of our boat captain, John Lipscomb, over more than 20 years, going up and down the river and really making routine observations month after month of the whole estuary, that there are at least 8 sites that if there are people swimming at a public beach, they're also swimming at these sites. So they're used as frequently as our public beaches, and they're on the river, and those are based on his observations. And then we have these 30 sites that are also mapped here, the greens and the blues, that show locations where there is a public or an open water swim event, and either the place where swimmers are invited into the water or where they're getting out of the water, those kind of splash points. So you can see, again, just demonstrating there are a lot of options. There are a lot of places where people have been swimming. Now, unfortunately, not all these places are going to be viable as beaches into the future. We have already seen significant sea level rise in the last century. We're going to see it accelerating over the coming decades. So this is a map that our former colleague, Jen Epstein, produced after her employment at Riverkeeper. But this shows a snapshot that just gives a taste for the understanding that many of our access points on the Hudson are going to be inundated. They're going to be challenged to support the uses that they have today. That doesn't mean that there aren't going to be options, but it means we need to be smart about figuring out if we're going to start, open a new beach to make sure it's going to be there when we want it in the decades to come. So as I've said, there are challenges. So the beach regulations are strict. They're so strict that we haven't seen a beach open on the Hudson in our living memory. We have seen just the one river pool at Beacon open and permitted in that time. Sea level rise, as I said, is going to put at risk some of the sites that are currently in use or could be. And the water quality, as I've said, and you'll learn more, can be risky after rain. And that means that even our current beaches have been closed at times as the water quality has failed to meet the Department of Health regulated cleanliness. So what do we need? To have more river pools and more beaches, we need strong standards that are going to protect people in the water. We want that. Riverkeeper always fights for strong standards, protective standards. But we also need flexible regulations of beaches. We need beach management protocols that recognize that in a river, you're going to have more variable water quality. You're going to have a lot of days when people can swim safely. We want them to swim on those days. On those days when it's not safe, we need to have the strong testing protocols and strong beach management protocols that close the beach or river pool only on those occasions. So we believe we can have a lot more swimming today if we had more flexible regulations. We're working on that. The New York Swims Initiative is a great visionary effort that Governor Hochul announced. Is really built on the catalyst of the Plus Pool, a floating pool that's proposed and getting some pilot testing now in the East River in New York City. We advocated successfully to make sure that program will be able to support not only the Plus Pool and not only neighborhood pools, which are really important, but also new beaches, new river pools in our natural flowing water. So that's really important that we see that. And of course, we have to continue to see our water quality improve, and we'll touch on that more later in the presentation. For water quality, I'll turn to my colleague, Shannon.
Hello, everyone. So now that we see, the river's being used for swimming, people are excited to use the river for swimming, and we want to make sure that we're providing information to the public to make informed decisions about staying healthy if they are going to recreate in the water. And we've been doing this work for a long time, and we're currently in the process of expanding the number of locations and different parameters that we measure to ensure that the water is safe for recreation. So I'm going to walk through that right now. Can we go to the next slide, please? So many of you are probably familiar with our monitoring program. This map you see on the right-hand side of the page is from our web page. You can go on that web page and you can look at all of the locations where we monitor. So that's at 77 locations in the estuary and over 100 tributary locations. And so what we do is we take our boat and we go from New York City up to just past Troy once a month, May through October. And during that time, we stop at 77 different sites and we collect water samples and we analyze water quality. So what we're primarily looking at is something called fecal indicator bacteria, which is a bacteria that indicates feces. It's aptly named. And I'll get into a little bit what exactly the details of what that is in the next slide. But on our boat, we are collecting those fecal indicator bacteria samples, and we are collecting information on the water salinity and turbidity and the chlorophyll concentration, which is a measure of algae. So these kind of things help us to understand water quality in the estuary. And then in the tributaries, we work with a number of volunteers, very dedicated, just fantastic community scientists who help us to collect samples, and we analyze those samples in our lab in Kingston, also for that Enterococcus fecal indicator bacteria. And again, all of that data can be found on our website. You can click on a location and you can see the current data and go back and look at data going all the way back, in some cases, to 2006. Different locations have different amounts of data associated, but definitely check out the website if you haven't. Maybe Katie can link the website in the chat. Okay, so like I mentioned, fecal indicator bacteria is a category of bacteria, and there's one type of bacteria, Enterococcus, that we measure. And the reason that we measure Enterococcus is because that survives well in fresh and saline waters, and the Hudson River is an estuary, and there is an amount of salt there, so it makes Enterococcus a good indicator for us to use, and that is indicating feces. So it could be feces from humans, it could be species from other warm-blooded animals, so things like cows or deer or geese. All of these things produce fecal indicator bacteria, and the Enterococcus and all fecal indicator bacteria as a category are not toxic themselves, but they indicate the presence of other toxic bacteria, viruses, or protozoa that are also found in the gut. So those bacteria and viruses are a little more difficult to measure. So instead, we measure Enterococcus, and we know that if Enterococcus is there, these other harmful bacteria, viruses, and protozoa are also likely there. And that means that when it reaches a certain level, a certain amount of Enterococcus, we would issue a beach advisory, or EPA would issue a beach advisory, or DOH, depending on who's managing the beach, would issue a beach advisory that would say the Enterococcus is too high at this beach. If it's a freshwater beach, they could also be using E. coli. That's another fecal indicator bacteria that you can't use in saline waters. So if either of those reach a certain threshold, we give a beach advisory, we say don't swim. And so that level is different whether you're taking an average of many samples or if you just have one sample count. And so if you look on the Riverkeeper website, you'll see a red or a green dot, and that will indicate whether that has passed an EPA threshold for safe recreation. So it's very easy to see on our website. Green, safe for recreation; red, above the threshold for safe recreation. And like I mentioned, this Enterococcus testing is done partially on our boat. We have equipment on our boat to be able to measure Enterococcus. And then for the tributary samples, it's in our laboratory in Kingston. Okay, so this, begs the question, is the Hudson safe for swimming? What has all of this data shown us? And so there are some generalizations that we can make because, again, we have a lot of data going back to 2006. So in general, many of the tributaries, many of the shorelines in New York City and abatements, and the sort of capital region river system, and some of the more populated urban shorelines tend to have less, more beach advisories. So more frequently is that water not safe for swimming currently. Many tributaries and shorelines are in better shape, and those are more often safe for swimming. And the river away from shore locations, so if you're on your boat and you're going to jump in, you're in sort of mid-channel, and definitely plenty of shorelines are very safe for swimming. And I'm going to get into a little more detail here in the subsequent slides. So if we look at the river overall, so this is the river recently. So I just took data from 2022. So in the past few years, if we look at, all of the data that we're collecting, how often are you safe for swimming and how often are you above a beach advisory where we would say it's not safe for swimming? So in general, 61% of all of the samples that we collected at those 77 locations going once a month, May through October, back to 2022 in this case, in general, 61% of those are safe for recreation. And when we have dry weather, so when we don't have rain, it's 74%. So over 3/4 of all of the sites in the river at all of the times we've taken a sample during dry weather have been safe to swim. So this really indicates to us that when it's safe to swim, or that when we have dry weather, it's pretty safe to swim in most parts of the Hudson. Now that number drops significantly after wet weather. And we're going to get into this webinar why exactly that is. But in short, when it rains, all of the stuff that's on the ground washes into the river, and infrastructure and wastewater treatment plants that are not upgraded and have been operating for a very long time are not able to capture that huge influx of water and end up having to release untreated sewage. So during wet weather, you have everything washing off the land, and then you have a preponderance of sewage, raw sewage kind of overflows going into the system. So I can go to the next slide. Okay, so now you may have the question, okay, if you want to be sure, where is it kind of safest to swim? So in other words, where is it most frequently do you not see advisories? So where is it most frequently safe for swimming? So what I did here, again, this is just since 2022 because things change over time. So we have this big data set, and that's one of the things that we're finding is that there are certain locations where things have trended much better over time and where they've trended worse. So we're just looking at sort of recent data so you could make a decision today. So at these, I think that this cut off a little bit, for some reason in the slideshow, because I'm only seeing to 15, and I think we have a few more sites listed. Yeah. There's a 16 here, but these are all of the sites and they're mapped here. This is not a ranking. It's just so that you can see where the site is on the map. So at these locations, the samples that we took, 80% of the samples that we took at all of these locations were safe for swimming, 80 or above. Okay, so this means that at these locations, 80% of the time, it's safe for swimming, rain or not. 80% of the time, it's safe for swimming. So these are kind of the safest options. And, again, we always want to be cautious during wet weather events. But these are the sort of the safest places. And you can see there's a lot, like we mentioned earlier, of those mid-channel locations. And that's really just because it's diluted. You're not as close to where everything is washing into the river from the land. Okay, and then can we go to the next slide? And then just to really illustrate this point further, if we look at this same metric, so sites where 80% of the time it was acceptable for swimming, you can see that during dry weather, those sites are in green here. There are a lot more sites where it is safe for swimming in dry weather. And when we have wet weather, there are far fewer sites that are safe, and many more sites fall into a category where when it's raining, half the time it's not safe to swim. So that's what the red dots indicate, that if it's raining half the time, it's not safe to swim there. So you can see that rain makes it just a huge difference in terms of how often it's safe to swim somewhere. And that is really a problem if we go into the next slide, because as Dan mentioned, in terms of access, water quality is also hugely going to be impacted by climate change. So if we look at, this quote from EPA, they're saying climate change is likely to cause multiple direct and cascading effects on water availability, water quality, and aquatic life that could impact human health and the environment. And I think realistically, if we were to rehab this quote, we would say that climate change is already causing these problems. And we know that they are impacting human health and the environment. We have the science now to definitively say this. And I also don't think it's surprising to anyone, even if you're not a scientist, you can see and feel those changes, right? So what does this look like in the watershed, in the Hudson River watershed? So we know we're going to see more precipitation. So both the frequency with which we have precipitation events and the intensity of that precipitation is going to increase. So what that means is that we're going to have more of that runoff coming off of the land and more of these combined sewer overflows. So these are when wastewater treatment plants take on too much water and they have to release that raw sewage because they can't treat all the water that they've just been inundated with. And again, both of these things result in a lot of enterococcus and fecal indicator bacteria and all of the hazardous bacteria and viruses that are associated with that. And that those all pose acute health risks, which mean if at that high level you could get in the water, you could get a stomach, a gastrointestinal illness, you could get a rash. These are things, these bacteria and viruses associated with fecal contamination cause acute health effects. It's a lot different than something, we'll get into some other contaminants like, PCBs or other chemicals where you really need to be exposed for a long period of time and a really high concentration before you might see something. These are all acute health effects. So along with that precipitation increase, we see more turbidity, and turbidity increases the persistence of Enterococcus. So these bacteria, fecal indicator bacteria, and all of the associated bacteria and viruses will die over time and in the water. They're supposed to live in the gut. They're not supposed to live in saline waters. However, things like turbidity, which will increase because you're bringing all this soil off the land with all the heavy rain, that kind of shields these fecal bacteria and viruses and helps them live longer. So that means that the risk goes up. So we will also see increasing water temperatures, same as air temperatures. And so that means we'll see more harmful algal blooms. We're already seeing these. This is something that we're incorporating more into our monitoring program. They're not likely to be a huge issue on the river. They're more of an issue in standing waters. But similar to the fecal bacteria, harmful algal blooms and the toxins that are released in those blooms cause acute effects to humans and pets. So we are, again, trying to incorporate these into our monitoring program moving forward more and more. The increased water temperature also decreases drinking water quality. We're talking about swimming today, but there's 100,000 people who rely on drinking water from the Hudson. And it impacts aquatic species, which, where they can survive. Both survival and reproduction, all of these things are dependent on habitat that meets certain conditions. So as that changes, where fish can survive and thrive changes. And then lastly, we'll see sea level rise. It's an estuary, so we will also see sea level rise along the estuary. This will cause the salt front to move north. It will impact aquatic species, and it will cause saltwater intrusion. So if you have a drinking water source, a groundwater drinking water source that's close to the Hudson and the salinity increases, that salt water is capable of getting into that drinking water supply. And then once there's salt in the water, it's pretty impossible to get out. So that's another issue for drinking water here. But again, we're talking about swimming, but just talking about climate in general. Okay, so let's go to the next slide. Just to wrap it up here. So we know that this precipitation is going to result in more beach closures. That's already been the case. More days where water quality would qualify as a beach advisory, as not safe for swimming. But this is a solvable problem. So the majority of this bacteria are entering the system because of infrastructure failure. These treatment plants can be updated and upgraded to be able to deal with this influx of water during precipitation events. But it requires money and political will. And this infrastructure is just very old. So as climate change progresses, it's even more important that those investments are made, because this is actually a solvable problem. Better management for the things that are running off the land, whether that's, agricultural management and best practices for spreading manure, or dealing with animal waste, or dealing with urban runoff and practices for dealing with things like pet waste. All of these things are managerial problems that can be solved. And there's lots of evidence they have in various times and places. Okay. And we're working on all of them. And then another solution that we see is to have information. So really that's the purpose of our monitoring program. And we are in the process of expanding our monitoring program right now. So we have more information, so that not only can we provide the public with information so they can make personal decisions, but we can provide information to municipalities and to regulators about, water quality problems, and how those may be tied to infrastructure, and work with communities to try to find solutions. And we do that by understanding the problem, and we understand the problem by collecting data. So we are in the process of expanding our monitoring program, And in 2025, our program will include more swimming locations, both formal and informal, more locations in environmental justice communities. We'll include new parameters that will help us to understand how climate change is impacting the system. And we'll be trying to collect as much data as possible that can be used for advocacy by communities and by our organization and other organizations. Okay. So just want to touch on two things because we're talking about water quality and we're talking about swimming and we're talking about the Hudson. So everyone is always, the question is always about PCBs. So I did want to address that. And I just want to say that in terms of swimming, PCBs are not an issue. So different chemicals are attracted to different types of environments. So PCBs are attracted to, you have oil and water. Some chemicals like to be in water, some chemicals like to be in oil. PCBs likes to be in oil. So what that means is that PCBs end up in things like fish. They bioaccumulate in organisms that live in that system. They partition into that system. There's not a lot of free PCBs just floating around in the water. And even if there are some, you would need to ingest just a huge amount of water for them to be a problem. Like you just have to be going out and drinking this water all day long, every day, straight from the shore. And even then, I think the risk would be really low because the PCBs don't really end up in the water column. So in terms of swimming, PCB is not something to worry about. Now, in terms of eating fish from the river, that is definitely a concern. And we're doing a lot of work right now to push EPA to make sure that the cleanup is sufficient so that folks who do need to rely on fish from the river can do so. And Katie will post some links if you're interested in taking action and helping with that work. Check those out. Okay, and then next slide. Okay, so last slide, and I'm sorry, I feel like I've taken a little bit too much time here, but the other question is about harmful algal blooms. I mentioned earlier, this is when you have a certain type of algae that grows when there are nutrients like nitrogen and phosphorus and heat. Those are the conditions that are needed. That algae then will bloom. And so when it blooms, it will, the algae contain toxins that again can be harmful acutely to human health. So we are working to incorporate some of those algal toxins into our monitoring program. But again, this is more of an issue for things like lakes, not so much for swimming in the Hudson. However, as climate change progresses, if things are hot enough, if water is not moving in certain locations, it is possible that we could see these on the Hudson. So that's why we're including it in our monitoring program so that we can kind of, make sure that we're on the lookout. And DEC actually has a webpage where if you see something that you think looks like a harmful algal bloom, you can report it to DEC. So take a couple pictures and use this link and we'll connect you to DEC or make that report for you. So definitely something to keep an eye out for. So yeah, so Dan, we'll talk about, how are all these fecal indicator bacteria getting into the system? What is going on here?
Yes, our favorite topic. How does sewage get in the water untreated? So here is the consequence of that sewage in the water when it's more visible. Shannon talked about how to test for the risk, even if the water looks normal, but there are times when it's egregious. And these are some photos that show when it's very visible, when the manhole is popping off the street, when the water looks murky and gross coming out of a pipe like that. It sometimes is, murky and gross because it's filled with untreated sewage. And of course, the town beaches or the beaches can then sometimes be closed as a result. So we see those physical examples at too often. Get this going. So why is this important? This chart shows the volume of wastewater of our sewage that is treated and discharged into the Hudson River watershed every day These bar charts are in million gallons per day. So you can see that big one at the bottom from the North River treatment plant in Manhattan that discharges to the Hudson River. It's over 150 million gallons a day from that one plant, the single biggest discharge on the Hudson. But you can see there the smaller numbers next to those bar charts are the number of treatment plants and the number of communities that contribute to each of those bar charts that show the volume. And you can see along the left-hand side, going roughly north to south, how the tributaries contribute and the infrastructure in the communities along those tributaries. So the Upper Hudson, the Mohawk are huge tributaries with cities and villages along them. So there's large volumes of discharges that come in via those tributaries. Same with the Wallkill River and the Rondout Creek, which together form the second largest tributary next to the Mohawk on the Hudson. The darker blue bars here are the communities and they're grouped by region, but the communities that discharge directly into the Hudson River estuary. So there are 2 points to make here. One is that there's a large volume of wastewater that we ask the Hudson to help us with. That's because we have a lot of people in our watershed. We have the Hudson River watershed is been settled, for thousands of years from Native Americans, and then intensively since colonial times for 400 plus years. So we have a lot of people, a lot of waste that needs to be managed. When it's managed well and treated, we can deal with this and have fishing. I'm sorry, have swimming in many locations safely. When it's not managed is the problem. And so I'm going to go through some of the ways that raw sewage gets in the water without being treated. The most obvious one and the one that Shannon mentioned a couple of times are combined sewage overflows. So this graphic shows what a combined sewer overflow does. On the left side, you see what happens in dry weather, what we want to happen all the time, which is the flush toilet goes into the pipe and that pipe leads to the treatment plant. It gets treated, cleaned up, and then discharged back to the water. What happens in rain is that same water that you see on the street pooling up and going down the storm drains next to the sidewalk, that same water goes into the same pipe carrying the sewage, and all of it overflows by design into the river. There are hundreds of locations in our that happen where this occurs. 450 plus in New York City alone, in the Hudson, East River, and the other waterways around the city, and then hundreds more up the Hudson from our older river cities and in the Mohawk River. So these are the subject of what are called long-term control plans under the Clean Water Act, where the communities responsible for these pipes are required to ratchet down the amount of sewage that is overflowing. We see improvements happening. There was just an announcement in Albany about a big sewage infrastructure project fueled by our state funding that Riverkeeper fought for over many years, the Clean Water Infrastructure Act, also from our federal funding, the bipartisan infrastructure law. These state and federal pots of money are tremendously important for fixing these local problems because they're expensive to address. So if the burden falls all on the local community, they're not going to happen, or they're not going to happen affordably. Those state and federal sources really help to help those communities invest. The other one I want to mention on this slide are what are known as illicit discharges. Those are when somebody's toilet flush pipe is connected right to the storm drain. And sometimes, because these cities are old and they've been built over time, there will be discovered that whole neighborhoods are hooked up incorrectly, or at least certain properties. So it takes an investigatory approach to find those connections in the system and correct them. The other problem is more about leaks and leaks that cause overflows from our old infrastructure. So the pipes that are underground are meant to carry the sewage in them without spilling. But because they're so old, we have clay pipes, we have old iron pipes, we have all kinds of different materials that have been compromised over time. They're crushed under the weight. Freezing and thawing cycles have affected them. And as a result, there are cracks in these pipes. So that can result in both infiltration and inflow. Infiltration is when groundwater and stormwater seeps into those pipes and then causes overflows or other problems downstream or downstream in the pipe system. Or there's cases where an individual home might have their downspout from their gutters hooked directly into the sewer system rather than the stormwater system, or rather than really what should happen, which is discharge to the open ground where it can seep in. That's the appropriate thing. All of these conditions can cause overflows, and they're all what we want to try to address. And again, it's disgusting. Like we need data. Everything that Shannon talked about is critically important. Some of this is so obvious. I bring this message to regulators. Even just today, we're talking to some agency folks about this. It's like, we don't need data if there are flushable, so-called flushable wipes washing up on the shoreline, as they unfortunately do with some regularity on this shoreline shown here in Yonkers, which is also the site where the Center for the Urban River at BZAC brings students, because it's the only access to the river where you can go down for water sampling, where you can learn about ecology, where you can take in the grandeur of that landscape with the Palisades across the way. That's what we want from our waterfronts, not sewage debris and toilet waste washing up on the shoreline. So what do we need to do? We need the money to keep flowing from the state and federal governments, and we need the local communities to get the planning done to be able to take that money and put it to work. They needed to fix the inflow and infiltration, investigate and find those illicit discharges, and reduce the combined overflows. Those are the slides that I showed, those categories of ways that raw sewage can enter the water. In some communities, there are additional strategies. In Westchester County, we had formed and helped to form this Westchester Coalition for Clean Water. One of the main goals of that coalition is to argue for consolidation of the county's wastewater system. Right now, each municipality owns its own pipes, but they then combine and are treated by these big regional county-owned treatment plants. So for instance, Yonkers, the largest of these, treats waste from 22 different municipalities. 22 different municipal budgets, 22 different municipal sewer operator or sewer, pipe maintenance folks. By consolidating that under a single management structure and really targeting the most important problems first, we really feel like that can help be a part of the solution in getting more fixes done faster and achieving better water quality, not only in the Hudson, but in the tributaries, because that's where the leaks are having the most effects. We need to make sure the communities continue to have access to the the federal and state funds. Often smaller communities really struggle to make use of the funding that's available. These are big projects. They take a lot of work. I live in Dutchess County, and to my north is the village of Red Hook. Just went through more than a decade of dogged, persistent effort to get grant money and the plans in place to just put sewer systems in the central part of the village. Incredible effort, and these local officials deserve all the credit in the world for the persistence that it takes to make these things happen. They're not easy. We need to find ways to help make sure it can be easier and get done, because the projects are so important. And finally, we do need to improve watershed management. Shannon touched on this a little bit, but the sources of contamination entering our waterways don't only come from our sewer systems. And if we have forested stream buffers along our creeks and streams, if we have culverts that are big enough to pass floodwaters, if we have floodplains that aren't built on but are and aren't paved over but are open to absorb those floodwaters, practices like this that help to restore the integrity of our watersheds and let water flow as it needs to flow also have significant water quality benefits and significant habitat benefits for the critters that live among us. So those are strategies that we need to pursue as well. And finally, the novel coalitions, the coalitions like the Westchester Coalition for Clean Water or the Hudson 7, these bring together people as advocates in ways that can help us achieve great things, big things that seem impossible. And those are the things that Riverkeeper is kind of our stock and trade, and what we're proud to be able to do is to advocate for all these things at once as well as we can. So we've talked about a lot of solutions we're working on, a lot of things that we want communities to be working on. For you, there's a lot you can do. most immediately today, it's these two things. We have a petition that is basically a simple statement saying, you want to swim in the river, you want to swim in the river where you live. That's what I want. It's what I think we all want if we're here. Sign that petition. It gives us people power. It lets us go to decision makers and say, look, hundreds of people, thousands of people are saying that they want this. That helps all of the arguments that we'll make. And please, if you can, if you have extra dollars around the house, please donate, become a member. That again gives us more power. It also, our members give us standing when we have to bring a legal case. We need a member who has affected by a harm in the environment that we can then pursue a legal remedy for. So it's tremendously important for a number of reasons. So I'll leave this slide up, and I think we have a few minutes for questions, and I think Katie can help prompt us and take us out to the end.
Absolutely. So thank you both, Dan and Shannon, for this wonderful webinar. It's been very informative, and I will have to look back at the recording so that I can also help relay the information that you both have shared tonight, particularly at tabling events. And then, yeah, so we can definitely go through the questions that we have. Given that we have just about 4 or 5 minutes left, I can go through the questions that were not necessarily answered in the webinar tonight. So I will start with question number 1, and that is, are there any tests that distinguish human fecal matter from Canada goose fecal matter? Because to the attendees' knowledge who presented this question, Canada geese mainly go in the water or on land near the water. And Shannon, you would like to address this one?
Sure. Yeah. So like I mentioned, this is a huge issue because fecal indicator bacteria can be in any warm-blooded animal gut. So it could be a human, it could be a geese, it could be a cow. And all of these are significant sources of fecal indicator bacteria in most watersheds. And so we can use, scientifically speaking, and Riverkeeper has been working with some laboratories to be able to do this in certain locations. But yes, you can measure DNA of specific species. So you can quantify how much DNA is actually there. How much is human, how much is geese, how much is deer, how much is cow. So there's a number of different markers. And you choose which ones you're looking at based on what you think might be there. And then, yes, you can measure the DNA and differentiate these different species.
All right, thank you, Shannon. And just so everybody knows, before I move on to the next question, I added the links to the chat for one, becoming a Riverkeeper member, and second, the link to our petition. So that really will add to the momentum of our cause in supporting more swimming access on the Hudson River. I also like to point out one attendee has listed a whole bunch of places that he would love to swim in the river. So I just want to thank that attendee, and you could definitely put as many places that you would like to legally swim in the Hudson or along it. Okay, so next question is, are tributaries typically more or less contaminated than the Hudson River? And I think Shannon can address this one.
Yeah. So they tend to be more contaminated. And one of the main reasons is that there's a whole lot of water in the estuary and there's just less water in the tributaries to dilute out things like combined sewer overflows or other types of runoff. So there are a lot of sources within those tributaries as they, wind their way up through the watershed, and less water. So that contamination is concentrated. And so for that reason, the tributaries tend to be more contaminated and the tributary mouths tend to be a bit more contaminated along the main stem.
Okay, thanks, Shannon. Our next question is probably a very common question that folks like to ask, and that is, how far north does the saltwater line go? And second part to that question, are there benefits to saltwater relative to northern Hudson River water? And maybe Dan, you could address this one.
So on the first, the salt, what we call the salt front, which is sort of the measurement where it's considered an estuarine measurement of salt, shifts. It's not one location, and it is different by season. It's really different based on how much fresh water is flowing into the Hudson River from all of its watershed from the tributaries, because that fresh water kind of flushes the salt water out and down. So in a drought summer, I don't think we're seeing the conditions right now this year because we've had some rain, but last year we were seeing the salt front really creep far north in the summertime, whereas it's typically down, like if you're in Haverstraw Bay in Westchester County, that's going to almost always be saline, but then up through the highlands to about Newburgh is sort of as far north as typically it goes. But in a drought year, you'll see it reach as far as Poughkeepsie and even a little bit north. And to the point about, or the question about drinking water, that's where it becomes a concern for the communities that do draw water from the Hudson, because it starts to exceed the level at which, at least right now, the level that gets exceeded has been a threshold that the Department of Health recommends people don't drink if they are on very low sodium restricted diets for other health reasons. Now, interesting, just as a side note, I have been impressed to learn recently that when that condition will happen, occasionally in the Hudson because of the salt front, many of our water supplies around the region exceed that value routinely just because we've used so much road salt. So there are other ways that salt enters drinking water other than the salt front. For the Hudson River supplies, for those communities, it's the salt front. It's that push up from the ocean, and sea level rise will cause that salt front to push further north. And it's one of the reasons we successfully advocated for the state to study and model the future conditions so that those communities can really plan for the future conditions. Because right now it's a question like how quickly and how severely that change will happen.
Thank you, Dan. And we'll just permit one more minute for one more question. And I think this will be an interesting one. Is Ulster County and its residents considered an environmental justice area, since the channeling of water to New York City prevents fresh, clean water from the Catskills that normally would have reached Ulster County residents and diluted pollution from that area?
All right. Well, there are a few threads to that question. And it's getting into how the Ashokan Reservoir is managed, I think, in implying the interruption of freshwater flow. So first of all, just the basic question on, are there environmental justice areas in Ulster County? There are a couple ways that our state government sort of recognizes communities that are at risk of having environmental justice problems, which is basically an overburden of environmental harms, and those are unfortunately typically have their effect in communities of color and less wealthy communities. So are there communities designated like that in Ulster County? Yes, parts of Kingston, parts of New Paltz, Ellenville, and perhaps others. Those are the ones that I have kind of my mental map. And the other question sort of, but that doesn't exactly connect to the way the questioner put it. It's not because of the presence of the reservoir that those areas are considered environmental justice areas. There are downstream impacts that the communities along the Esopus Creek have lived with because of the way New York City has managed the Ashokan Reservoir. Fortunately, a management change recently announced will, if it's adhered to and it's followed as advertised, will result in consistently cleaner, less turbid water coming out of the reservoir into the Esopus Creek. So that will be an improvement. Doesn't solve every problem, but it's a significant and positive change.
All right, thank you, Dan. And we will now have to wrap this out. I'm sorry that we cannot get to everybody's questions, but we just want to first thank everybody for taking the time out of their evening to spend with us to learn more about how we can support more swimming access in the Hudson River. And yeah, definitely let us, we'll let you know, more updates as we, work on this. Definitely, check out the petition that we just linked here, and I'll also add the link to the follow-up email, to all of you. So thank you very much, and hope all of you have a good night. We will also provide this recording, and we'll talk soon. Everybody have a good night.